Hi, I'm Eric, and welcome to You Too Can Do the Math. Today we're going to be started and talking about the quadratic equation. Now, many of you may be familiar with the quadratic equation. It oftentimes shows up as ax squared plus bx plus c is equal to 0. And then many of you will have memorized the answer that when this equation is equal to 0, the values for x are negative b plus or minus the square root of b squared minus 4ac over 2a. So that's a mouthful to remember and can be quite challenging. So today we're going to talk about where this comes from. And specifically, we're going to talk about a problem-solving method that involves 3 steps. 1, figuring out what do you want? In terms of solving a math problem. The second, what do you have in order to help you solve it? And then finally, what connects what you have with what you want? So what connects them? 3 easy steps for problem solving, and we're going to illustrate how that works today. So we're going to start off by labeling this quadratic equation as what we want. If you don't know what you want in a mathematical problem, it's going to be very hard to get the right answer. What you want is a starting point. It doesn't tell you the answer, but if you happen to cross the answer, or if you're working hard and you come across the answer, you want to be able to identify, is this the answer? Can I test if this is the answer? The second part of this is, what do we have? So for some problems, we don't start with very much. In this particular case, we've got a quadratic equation that we've set to 0. And so finally, we want to know what connects them. So to start off, this what want thing is a big nasty mess, but this have thing isn't too bad. So let's start with the have. Start with have. And that's ax squared plus bx plus c is equal to 0. So what does this mean? This means I have bad, sloppy handwriting, and we will do that over again. So this means that this equation over here goes to 0. So this is looking for roots. And we want to find x. So we might recall from multiplication that if I've got a root, I can rewrite the quadratic equation in terms of a product, and in fact, in terms of 2 products, where x1 is a root and x2 is also a root. So these are valid solutions that get us to 0. So if x is equal to x1, then this term is equal to 0. And if x is equal to x2, this term is 0. So 0 times something is always 0, unless you've got infinity or something crazy running around like that. So we know that our answers, which is what we want, are just x1 and x2. Yay, we have now solved the problem. We have gone from trying to figure out what x is to figuring out what x1 and x2 are. Okay, this is progress. This is not so bad. So how do we figure out what x1 and x2 is? Well, what if we can make this thing, make this look like this. So we've got our original equation. If we can change this around, maybe we'd have a crack at being able to find x1 and x2. So the first thing we're going to do is we're going to take it times a on both sides. And that's going to give us a times x minus x1 times x minus x sub 2 is equal to 0 times a. So 0 times a, this is just 0. So that's nice and well behaved. And what are we going to have over here? Let's do a FOIL. Okay, so we've got x times x is our first. Now we're going to do outer. So that gives us x times x2. And we notice that we've got a minus sign here, no minus sign here, so we're going to have a minus sign there. Then we're going to do inner. So we've got negative x1 times x. And then we're going to have last. So we've got negative x1 and a negative x2. I'm going to put a positive there, negative x1 times a negative x2. Those two negatives are going to cancel out, and we're going to get positive x1 times x2. Put another parentheses, and we know that this is equal to 0. So let's simplify this out. What do we got? We got a parentheses x squared, and here we've got x1 times x, and here we've got, x2 times x, and here we've got x1 times x. So there's a common factor of x there. So I'm going to write this as x1 plus x2 times x, and then we've got plus x1, x2. So this is a lot of x's and only one little o. So let's keep in mind that this is a constant, and this is a constant, and that x's are nominal variable that, if it's a root, is equal to x1 or x2. So let's simplify this down a little bit more. So we've got ax squared minus a times x1 plus x2, x plus a x1, x2 is equal to 0. This now is starting to look like our original quadratic equation. So our half. And what we can do is we can match the terms. So we can see that in front of x squared, we both have got a. So that's fantastic. Now, in front of just the x term, on one we've got b, and on the other we've got negative a, x1, and x2. And then finally, for the constant term, on one we've got c, and one we've got this ax1, x2 thing. So let's match terms. By doing this, we're making these two equations the same. Make equations the same. Because if the constant term is the same, and the term multiplying the x is the same, and the term multiplying x squared is the same, and there isn't anything else, it's the same, the same, the same. Everything's the same. So how do we do that? Well, we start off by saying a is equal to a. Nice and simple, and if you get the and ran reference, all the better for you. So this is our x squared term. So notice x squared, we're just using this as a label. We're not actually putting that in the equation. We could, we'd have x squared on both sides and we could cancel it out. Then on the next term, we've got b is equal to negative a, x1, x2. So this is our x term. And likewise, we could have had x on both sides here, but it cancels out. And then finally, we've got c is a, x1, x2. A is equal to a isn't a terribly useful statement, but these two other things are pretty useful. We've got two equations, and two unknowns, x1 and x2. And everything else is known. We know what A is, we know what B is, we know what C is. So we're done. Everything's happy. Except we don't know what x1 and x2 are. Okay, well, let's solve that. So let's take B minus A, x1, x2. Don't forget the plus in there. Let's divide everything by negative A. Divide by negative A. So the negative A's are going to cancel out. And we're going to get negative B over A is equal to x1 plus x2. So we can see that x1 is equal to negative x2 minus b over a. So I'm just subtracting x2 from both sides. And then the x2 will cancel out over here and cancel out over here. And that's what we've got. So that's fantastic. We've identified one of the variables. So we can then substitute in. So we've isolated x1 in terms of x2. So now we've gone from two equations and two unknowns. Now we're down to one equation with one unknown. So we had ax1, ax2. We'll just substitute in here parentheses, because parentheses are always our friends. B over, wrote a 2 there. That was no good. Let's try that again. B over A. And then we've got x2. So we're substituting in. Substitute in. And let's work this. So now we've got, one equation and one unknown. All right, we've got this sucker on the run. It's all good. So what do we got? We've got A times negative x2 minus B over A times A x2. Let's simplify this out. We've got C is equal to negative A. Oh, almost forgot the other x2 there. Can't forget that other x2 or we're going to have some real troubles. Ax2 squared minus the A and the A cancel. So now we've got minus bx2. And if we shuffle everything over, we get, oh my, what have we done? bx2 plus c is equal to 0. We are back where we started from. The start. We are lost in the math forest. This is no good. So, we've gone all around. We've done a whole bunch of algebra. And we've gotten back to, something we know is true. So, but it's true. So, consolation smiley face. So how do we get out of this little rut that we're in? What do we do? How to escape from this math trap? So now I'm going to show you a trick. Math is a lot about tricks. The more tricks you can pick up and the more places you can see to apply them, the better off you might be. So if you remember back up here, we had this relationship, and we've got x1 plus x2. That looks kind of suspicious. That almost looks like we're taking an average of x1 and x2. Like we're trying to find the middle point of the roots. And if we divide both sides by 2, in fact, we can say, yes, this is the average of the roots. So this is some sort of midpoint. Averages can be very helpful this way. This is just the average of two things, but that's okay. And then all of a sudden, that looks familiar. Where does that look familiar from? we go back up to our original quadratic formula, well, wait a second, that's this negative b squared over 2a. That's the first part of our formula. That's some of what we want. So, we actually want this. So that's definitely a happy thing. So the question then is, so we've got part of what we want. How do we get the rest of it? So let's define a new variable. Variables are cheap. All we need to do is say x, and we're going to put a little bar over that for average, is 1/2 x1 plus x2. So now negative b over 2a is equal to x bar. So what if we wanted to go backwards? What if we wanted to go from x bar to x1 and x2? So let's set up and define x1 as x bar minus some difference, and x2 is being x bar plus some difference. So I'm just using the Greek symbol for delta. It's a little equilateral triangle here for the difference. N-C-E, D-I-F-F-E-R-E-N-C-E. My spelling is not that great. So here we've got the average, and here we've got the difference. So instead of talking about things in terms of positions, we're going to talk about it in terms of an average and a step away. So if you think about what this looks like, so we've got x1 and x2, and instead we're going to talk about some location x bar and going plus delta to get to x2 and going minus delta to get to x1. So we've still got two variables, so that's okay. We're not doing anything, particularly sketchy. And we can then write, if we go and add these two together, use a different color here. What do we get? We get x1 plus x2 is equal to 2 x bar. But what if we did some subtraction? So what if we had instead x2 is equal to x plus delta, x1 is equal to x bar minus delta. And if I just subtracted this whole thing from the top, I'd get x2 minus x1, and I'd see that the x bars would cancel out because they've both got a positive sign, and instead I get delta minus a negative delta, which is just delta plus delta. So x2 minus x1 is equal to 2 delta. And that makes sense because if I look at my diagram up here, I can see the distance between these two is 2 delta. All right, so we've defined two new variables. This x bar quantity, x1 plus x2 over 2, and we defined delta as being x2 minus x1 over 2. And we'll use some green for that. So we already knew that we could rewrite our first equation in terms of x bar. So what about our second equation? So our second equation, where was that? That was running around. Here we go. Here is our second equation. What if we look at rewriting that? So we've got C is equal to A, x1, x2. So that gives us C is equal to A. And let me get a little bit more space there. Always use lots of space. Don't be afraid to use lots of space. Use sticky notes. Use plenty of space. We've got C is equal to A. And so instead of x1, I had x bar minus delta, and then x bar plus delta. So I've got x1 is turning into this, and x2 is turning into that. And so what do we have here? We've got C, A, parentheses, FOIL again. So we've got X bar first, outer. We've got X bar delta. We've got inner, we've got a negative sign there. Our inner is delta X bar. And then we've got last. So we've got plus, oops, no, we don't have plus, we've got a minus. We've got minus delta times delta. And so you notice that we've got a plus delta x and a minus delta x. So these two cancel out, and we've got C is equal to A, X bar squared, minus delta squared. And when I make some video about foiling and multiplying things together in algebra, we'll talk quite a bit about this. But that's for a later date. So let's divide both sides by A. We get C over A is equal to X bar squared minus delta squared. Now we know X bar already. And let's get that. So that's just equal to negative B over 2A. Highlight that. Yay, we know that. So again, we're in the situation of we've got an equation here where we know this, and we know this, and we don't know delta. We can find out what delta is pretty darn quickly here. So we can say X bar squared minus C over A is equal to delta squared. And all we're doing is just adding on delta squared to both sides and subtracting off C minus A, and then negative C over A on both sides. So now we've isolated out delta. So now we know delta. But do we really know delta? Let's substitute in and see. So delta squared is X bar squared, we know that. So we've got B over 2A, quantity squared minus C over A. This is looking pretty good because here we've got just A's and B's and C's, and here we've got delta squared. So let's simplify this a little bit more. We've got B squared, because the negative goes away, over 4A squared. Now I've got minus C over A. So what if I want to combine those fractions? So if I multiply top and bottom here by 4A and 4A, what do I get? I get a common denominator of 4A squared for both of them. I get B squared minus C4A, which we could just write as B squared minus 4AC. That looks suspicious. Familiar? Not sure I spelled familiar right, but that's all right. Well, no, it's not all right, but this is math class, so we'll let it slide. So let's take the square root of both sides. And now we're going to assume that delta is greater than or equal to 0, or there's going to be problems. Later on, if we talk about imaginary numbers, that'll stop being a problem, but for now it might be a problem. But if it's a problem, it means that we don't have any real roots, which means that it's a problem in and of itself. So we've got delta is equal to square root of B squared minus 4AC. And then if we apply that to the bottom for A squared, we've got B squared minus 4AC over 2A. So now if we think about our solutions, x1 was X bar minus delta. Well, that was just negative B over 2A minus square root B squared minus 4AC over 2A. x2, X bar plus delta, negative B over 2A plus square root of B squared minus 4AC. over 2a. We can combine those and say x is negative b plus or minus square root of b squared minus 4ac all over 2a. And we've won. We've got what we want. Hooray! Smiley face time. And that's how you do it. Hopefully this has been helpful. Hopefully I'll make some more videos. Leave a comment, email, whatever. Take care. This is Eric, signing off from the Fortress of Math in the Hinterland. Have a good night.